Hi, this is Instructor Beckstrom again, and today we're going to be going over Chapter 2.4, Direct Measurements. Alright, so today we're going to be talking about length measurements, angle measurements, and other types of measurements that we can use out in lots of different jobs, mechanics, welding, woodworking, other areas that we need precise measurements. So what kind of instruments do we use? Well, the most common ones that we generally think of when we talk about measuring lengths would be your standard ruler, perhaps a tape measure, even a digital measurement is often available now. So precision, instruments are created with varied levels of precision. So the more precise an instrument has to be, the smaller the scale division needed. So let's take a look at this ruler here. What's the precision of the following ruler? Well, if we look at the top, we see that it's divided into inches, and between each of those inches we have 8 intervals. So we can say that this is precise up to an 1/8 of an inch, or has an accuracy of 1/8 of an inch. So if we measure something, that's how close we can get to the actual length. Now look at the centimeters on the bottom. So the centimeters, between each centimeter number here, like for example between 4 and 5, we have 10 intervals. So we can say that's precise up to 1/10 of a centimeter, or an accuracy of 1/10 of a centimeter. We can also say it is graduated in tenths of a centimeter, and that's pretty much saying the same thing. So if we, once again, we measure something using the centimeters, that's how close we can get. Well, first, why don't you try your turn on page 145, and just make sure that you understand reading precision and accuracy on rulers. Now, let's try an example here. So let's say we want to measure the length of this black line here, and we were measuring in centimeters. So notice that this ruler here is accurate to within 1/10 of 1 centimeter, or 0.1 centimeters. So we're going to round that black line to the nearest 1/10 of a centimeter, and that's the measurement that we're going to use. So we see it's past 1 centimeter, but before 2 centimeters, but it's only one notch there before the second centimeter. So we can say that this is 1 and 9/10 centimeters, or 1.9 centimeters, abbreviated cm. So try your turn on the bottom of page 146 and try to do some different measurements there. Moving on, we can talk about digital micrometers. They're the modern ones right now that are used are accurate to within 1/10,000th of an inch. Now when I say 1/10,000th, I did that by seeing that here's my decimal point. I have tenths, 100ths, 1,000ths, 10,000ths. So that would be 1/10,000th of an inch. And the measurement is given as either a digital readout in inches or millimeters, depending on whether you're talking about usually foreign or domestic items. If you're looking at a car, if the car was made here in America, it's often given in inches. For like socket size, for example, if it's made in Japan or maybe made in Korea, you'll often see that the socket sizes are in millimeters. So reading let me go back up to there, reading a micrometer. So micrometer has usually 3 different scales to measure length on them, and you can see here's 4 examples. And what we do is we measure each one of those scales, and then we're going to add them all together to find the final measurement. So the first measurement, the least accurate, is the large numbers that you see here, like for example in this one 5, 6, and 7. So this one would be past the 7, so we're going to multiply that by 1/10 of an inch, because that's how accurate that is. And you can see down here on the bottom, I know it's kind of small, but they multiplied the 7 by the 0.1, and then the second measurement there is the 0.025 of an inch, and that's going to be after the 7 here. So if you see, we go 1 line past that 7, so we would multiply that 1 by the 0.25 and add that to our total. And lastly, we're going to look at the dial on the right side here, which is precise to 0.001 of an inch, or 1/1000th of an inch. And if you see here, it starts at 10, 11, 12, 13. So that one, we're going to multiply the 13 by the 0.001, and then take all of those numbers and add them together. So there's a good example in steps on page 148. And once you look at that, try some of those on page 149 under your turn. Okay, so we have the vernier micrometer. Vernier micrometers are accurate up to 1/10,000th of an inch. And they're used when you need very precise measurements. There's a good example on page 152, example 6. It's read in a very similar way just to the regular micrometer. And go ahead and try some of those. Look at the example. Try your turn on page 152. Next, and finally, we're going to be talking a little bit about protractors. Now, I believe there's a page near the back of the book that has a protractor that you can cut out and use if you don't have one. If you happen to be at the grocery store or stopping at Walmart or Target, you can pick up a clear one for very little, maybe 50 cents. And it'll just be nice to have, and plus you can use it in this class as well and on your tests. But these are used to measure angles. Now, it's important to remember that angles are generally going to be between 0 and 180 degrees. Well, at least the ones that we're going to measure. And depending on where we put the flat edge, depends on whether or not it's going to be between 0 and 90, and 90, 180 degrees. And an easy way to remember it is if the angle is acute, that means it's smaller than 90 degrees, smaller than a right angle, then your measurement is always going to be between 0 and 90. Now, if your measure is obtuse, means greater than 90 degrees, then your measurement is always going to be between 90 and 180. And not on this protractor, but on most protractors, they'll give 2 scales depending on where you put your starting side. So let's take a look at that on the next page here. So here we have a protractor. It's got the 0 through 180 going on the top, and on the bottom in the other direction it has 0 through 180. And the reason they have that is because you can put your starting side on either point here, either going to the right or going to the left, depending on where the angle that you're measuring is. And the one that we use is just basically going to depend on whether or not we have an acute or an obtuse angle, which measure we use. So take a look at this angle here. We see that in the upper reaches, it's exactly between 140 and 150, right at 145. And down here, it's right between 30 and 40, so that would be 35. So this angle is either going to be 35 or 145. Now remember what we said. We have to see if this angle is less than 90 degrees or greater than 90 degrees. In this case, it's definitely less than 90 degrees. So we're going to go with the angle that is 35 degrees. All right, well, thank you very much. I'll put some homework up, and if you have any questions, please let me know. Have a great rest of your day. Bye-bye.